Hey guys, so I'm just going to be working through, I think I have 6 problems that kind of go along with the review sheet that we're going to get right before our test, and so I just wanted to kind of work through some similar problems, get it back fresh in your mind. So we're just going to go ahead and get started, okay? So our first problem says, how many atoms are in 25 grams of nitrogen? Okay, so the first thing that I'm going to do is I'm going to draw my T-chart. Okay, now the thing that goes up in the top left is the thing that I know from the problem. So I know that I have 25 grams of nitrogen. Okay, now if I have grams here, that means I have to have grams down here, which makes sense because I can't go from grams to atoms. If you remember that little triangle, you have to go from grams to moles. Then you can go to atoms. Okay, you can't go from grams to atoms. You have to go to moles in between. Okay, so looking at my periodic table, I can see that 1 mole of nitrogen is 14.01 grams. So 14.01 grams is 1 mole of nitrogen. Okay? So if I put this in my calculator, this will cancel this, and I will be left with moles of nitrogen. Now, I'm looking for atoms, not moles, so I need to keep going, which is why I've drawn this other little extension to my T-chart here. So if I have moles of nitrogen here, I have to have moles of nitrogen here. And I know using Avogadro's number that 1 mole of nitrogen is going to be 6.022 times 10 to the 23rd atoms. Okay, so when I put this in my calculator, this moles of nitrogen will cancel out this moles of nitrogen, and I'll be left with atoms, which is what I'm looking for. So I'm going to go ahead and plug this in. So I have 25. And I'm multiplying that by 6.022 times 10 to the 23rd. And then I'm going to hit enter. And I'll divide that by 14.01. Which gives me 1.075. Because I'm rounding. So I don't know if you can see, but that 5 will round up that 4. And then don't forget back here at the end, we have that E, which means times 10 to the 24th. Okay. And this is atoms. Okay, that is our answer. Alright, so my next one says calculate the mass in grams of 9.2 times 10 to the 27 atoms of KCl. Okay, so again, I'm going to draw my T-chart. I'm going to put the thing that I know in the top left, which is I have 9.2 times 10 to the 27 atoms. And I'm trying to get to grams. So if we remember back up here, you can't go straight from grams to atoms, you have to go to moles in between. So if I have atoms here, I have to have atoms here, and my atoms equation, or not equation, but conversion factor is 6.022 times 10 to the 23rd atoms in 1 mole of KCl. But I'm not looking for moles, okay? So I got to keep going. So I'm going to put, if I have moles here, I got to have moles here, because that'll cancel each other out. And then up here I need to have grams, okay? But I have KCl. I don't just have K, and I don't just have Cl. So what I'm going to have to do is find the mass of potassium, which is 39.1, and I'm going to need to add that to chlorine, which is 35.45. Okay, so I'm going to do that real quick before I plug all this in. So 39.1 plus 35.45. So that is my value for there. And then I'm just going to go ahead and rewrite that, actually. Okay. And then I'm going to start plugging this in my calculator. Okay, so remember when you have these exponents, it can get real hairy if you're not careful with your parentheses and you're entering. So I'm going to hit 9.2 times 10 to the 27th, and then I'm going to hit enter, so that I don't even have to worry about that anymore. I'm going to divide that by 6.022 times 10 to the 23rd, and I'm going to hit enter, and then I'm going to multiply that by 74.55. Okay, so my mass in grams is going to be 113.8924 grams. Okay, now if we wanted to be real specific, we would say 1.139 times 10 to the 6 grams, but this answer will be fine too. Okay, so, just a second. Oh, sorry about that. Okay, getting back into it. So next we're going to calculate the mass of 3 moles of NaOH. Okay, so first we need to calculate the mole of 1 NaOH. Okay, now we can do this as a T-chart, or we can just do this regular, like without the T-chart. We'll do it both ways. So doing it the T-chart way, I know that I have 3 moles of NaOH, okay, and I'm trying to get to the mass. So I know, looking at my table, that I can figure out what 1 mole of NaOH is. So if I have moles up here, I have to have moles down here. And my value, my mass in grams, is going to be Na, 22.99, plus O, which is 16, plus H, which is 1.01. And that's the grams for 1 mole of NaOH. Okay, so I'm going to go ahead and put that in my calculator, and then I'm going to multiply that by 3. Okay, so the mass of 3 moles of NaOH is 120 grams. Okay, now the way that you do that without your calculator, or without doing it out in a T-chart, is you just find the mass of NaOH, which would be 40, and then multiply it by 3, which is basically what we did, but just without putting it in the T-chart. Okay, so next we have calculate the molar mass of C10H12N2O. Okay, so we could add it like here, but that's going to be insane and take a really long time and be annoying. So instead, we're just going to do some multiplication. Okay, so I know that carbon is 12.01, and I'm going to times that by 10, excuse me. Okay, I know hydrogen is 1.01, and I'll multiply that by 12. I know that nitrogen is 14.01, and I'll multiply that by 2, and then I just have that oxygen, which is 16. Okay, so 12.01 times 10 is 120.1. 1.01 times 12 is 12.12. 14.01 times 2 is 28.02. And then I have that 16 from that oxygen. So I'm just going to plug all of these in. And the molar mass of this molecule is 176.24 grams. Let's turn this over and 2 more. Alright, so calculate the number of moles in 47.5 grams of MgClO4-2. Okay, so I'm going to make my T-chart. I'm going to put the thing that I know up in the top left, which is 47.5 grams. If I have grams up here, I need to have grams down here. Okay, so I need to figure out the molar weight, not the molar weight, excuse me, the molar mass in grams of this. Okay, so remember when you have parentheses like this with a number outside, this number distributes into those parentheses. Okay, so this molecule has 1 magnesium, it has 2 chlorines, and it has 8 oxygens. Okay, so I'm going to find my weight of magnesium, which is 24.31, and then I'm going to add 2 chlorines, which is 35.45, and then I'm going to add 8 oxygens, which I'm just going to go 16 times 8, because I don't feel like writing 16 8 times. And that will be my answer, or that will be my value, excuse me, for how many grams the 1 mole of this thing weighs. So let's go ahead and start finding that out. So I've got 24.31 plus 35.45 twice plus 16 times 8. So 223.21 grams is how much 1 mole of this weighs. Okay, so I'm going to take 47.5 and divide it by 223.21. and that gives me 0.2128 moles. And then finally we have calculate the percent composition of each element in MnO4. Okay, so if you, this should be the most recent thing we've done. So what you need to do is we're going to take the individual element weight up here. So let's find magnesium first. Or no, Mn is manganese, excuse me. So manganese is 54.94. Okay? And then on the bottom is your total. So if we said that manganese is 54.94 and we need to add 4 oxygens to that, which 54.94 plus 16 4 times gives us 118.94. And then we'll times that by 100 to give me my percent. So 54.94. Oh, try that again. 54.94 divided by 118.94. And then multiply that by 100. So my magnesium value is 46.19%. Okay? Now, we can do this with oxygen. Okay? Where we can say 1 oxygen is 16, 4 oxygens are 64 over 118.94 times 100. So let me just put that real quick in. Oh no, that's wrong. Let me try that again. Forgot a decimal somewhere. That's better. Okay, so we have that, and we can call it there, or we can just take 100 minus your magnesium number, because there's only 2 elements in that compound, so we can just say 100 minus 46.19 gives us our answer, okay? So your manganese, I think I keep saying magnesium, I'm sorry, is 46.19%, and your oxygen is 53.81%. And those are your percent compositions. So, awesome. Hopefully this wasn't too terrible for you guys and you were able to follow along. Again, please hit us up if you have questions. Bye.